In this video, we're going to look at composite functions. So what are composite functions? They're essentially functions and functions. So if you have a look on the left, you have f of x equal to x squared, g of x equals to 3x minus 1. If you have if you have g of x inside of f of x, we call that f of g of x, which is here. Now, with the way that works, wherever you see g of x, you're going to put in f of x. So g of x is 3x minus 1. You put that into f of x. That's why you have this line here, f of 3x minus 1. Then because it's x squared, we're going to square the whole expression, which then becomes 3x minus 1 all squared, or if you like, you can expand it out. You can also do it the opposite way around, where instead of x here, we're going to write x squared because f of x is x squared. Thus, you get this expression. Okay, now there are special conditions for which the composite functions would exist. So for f of g of x to exist, a range of g must be contained in the domain of f. So remember, this symbol means contained. That means, let's say you have two lines. This line goes into the second line, like so. The line on the bottom means and equal or equal to. So similar to, greater than or equal to. If this rubs that would be great. Okay, so if f of x is equal to e to the power of x and g of x is equal to square root of x minus 2, investigate whether or not the composite functions of f of g of x and g of f of x exist. So, best way to do it is write down our domain and ranges. So then we have domain, range, and then this is for f, this is for g. Alright, so the domain of f, e to the power of x. Looks like that. So then our domain is all real. Our range is from 0 to infinity, not including 0. And then g of x, not y, is x minus 2, so it's here. It's a square root function, like that. So our domain would then be 2 to infinity. Oh, oops, wrong symbol. And the range will go from 0 to infinity. So once we have that, we then simply check whether or not the ranges fit into the domains. So let's follow the first line. I might rub this graph out. Uh-oh. Let's write that out again. Sorry, pressed the wrong button. I deleted the whole thing. Was it 0 to... No. That was all real. So 0 to infinity. This was 2 to infinity. And this was 0 to infinity. Okay. So let's check f of g of x. Range of g should be contained in the domain of f. So our domain of f is real, and the range of g is 0 to infinity. So this is a true statement. Well, 0 to infinity is within the real range, so that works. so that function exists, then f of g of x would then be f of square root of x minus 2. So wherever we see x, we're going to replace it with that. So that's e to the power of x square root x minus 2. And then let's check g of f of x. G of f of x would then have the range of f, which is 0 to infinity. And if it does exist, we'll go into 2 to infinity. Now, if you have a look, because 0 to infinity is actually bigger than 2 to infinity, this is not contained in. So g of f of x does not exist. Now, I almost missed the last little bit. It's f and state the domain. So the domain will always be whatever g of x is. So then it's going from 2 to infinity. Okay, so then we have another two functions. For the functions f of x equals the square root of 4 minus x and g of x equals to x minus 1, state why f of g of x is not defined. So f of g of x will then have the range of g being contained or equal to the domain of f. The range of g is all real. The domain of f is from negative infinity to 4. Best way to check these is just look at the graph. That's how I did it in my head. So the range is not contained if that doesn't exist. Alright, restrict the domain of g of x to form a new function h of x such that f of h of x is defined. So we want g of x to be contained. Now, we needed to go from, if you have a look at the line before, at max negative infinity to 4. So then g of x here, this is a straight line stretched down by 1. Instead of a line like this, we're going to cut it out so that it goes from negative infinity up to 4 here. So that means we need to find the x value for this so that it works. So 4 equals to x minus 1, then x must equal to 5, then this is 5. So long as we set h of x to be equal to the same function, however x can only be going from negative infinity to 5, this then works. Then all we have to do from here on in is find f h of x. So h of x is x minus 1, f of x is 4 minus x minus 1. Then that becomes 5 minus x, which you can see now the domain works. Alright, last thing, we need to check whether or not functions work. Investigate whether or not f of x equals to 1 over x satisfies the equation blah blah blah. Just simply plug it in. We have f of x equals 1 over x, f of y equals 1 over y, f of xy equals 1 over xy. So putting this in f of x plus f of y all over f of x y, because it's 1 over x plus 1 over y over 1 over xy. If we add the two on the top, we get y plus x over xy. Now, remember this sign means divide. So then divided by 1 over xy. Then remember, you keep the first fraction, change the second one to a times, then you flip it. Xy's cancel. So then we get y plus x, or in other words, x plus y. So we can see it satisfies.